I've given a presentation at UKNOF, I think a year or so ago on that, and this is sort of an update to that. Nominum, if you don't know, we do DNS software and things around DNS. Our chairman, Paul Mokopetrus, actually wrote the first DNS RFC, and we wrote lots of DNS code. So more recently, over the last couple of years, we also went on to analyze DNS data. And we currently research terabytes of data every day that we get from our ISP customers around the world. And we look for DDoS, bots, malware, or other things that turn up in DNS traffic. And with that findings, we try to do good and actually block some of them. I'm going to talk about that a bit later. So the history on DNS DDoS, initially when this problem was first talked about, it was on attacks on the authoritative servers that did DNS amplification. And we had out of that something like RRL that people used, and that was good at that time, but we'll explain later that can actually be harmful today. And we mostly do recursive DNS software, so we really weren't kind of affected by that. But then we found out that in our customers' network, there were lots of traffic going around that was using these amplification vectors, and it was actually the open resolver, or I call them open proxies in the home gateways, that were forwarding to their ISP's resolver and then using that as a mechanism to amplify data and kill others. And that was something that happened in 2013. And we then built protection in our software to stop that. And then 2014 was really, late 2013, 2014 was the year when the random subdomain attacks occurred. Now, a random subdomain is something you generate the first label of a DNS query randomly, and then for every query that you send to the server has to recurse. And if you do that with lots of server, you eventually kill the authoritative servers. I have a slide on that. And that was the thing that we mostly saw last year. And all of these attacks, I mean, none of these attacks ever go away. They just add on up to it. You might see different distribution on the attacks, and we certainly see different behavior this year with the attacks. So this is last year. Now, one of the things we did to categorize that is our DNS software can record every query it's gotten, and we can then analyze that. And one of the analyzation we do is we find out how many names are actually asked. So every fully qualified domain name is a name, and then we sort of count that. And the normal traffic you see down below the line it's usually something between 60 and 80 million unique domains that get asked there around the world. And when the random subdomains attacks started in 2014, these numbers get increased, and they are increasing rapidly. And if you see now, you're talking into the 5,000 million or more different names that are used. And there are so many because for every query there's a new name. So that's why these numbers are much higher. And the actual traffic that we see, and we've did that by analyzing that and then removing the attack domains, is pretty straight. So in 2015, the attacks changed. So the attacks last year mostly used the open resolver to actually, or open proxies to actually kill the authoritative servers, and they've used 100 QPS per open proxy to do that, and they needed a large chunk, but this chunk was available. And I have some ideas why they changed, because some of the protection that other providers put in. And this year, actually, we see more concentration. So people are probably using bots or something, and one of the funniest attacks we had was actually we had an attack that we analyzed as an ISP, and we asked them if he would sort of share the IP with us and we could do some research on it, and he did, because we've seen 8,000 QPS, and that's something, I mean, that's something maybe your DNS server answers on a normal day for all your customers or for a large chunk of your customers, but that's not something you see from a single IP. So we were curious to find out what that was, and we found out that it actually was surveillance camera. So all of these devices that are out there that run some form of software can be abused to do stuff like that. And I'm going to show some of that later. So this is a slide we took sort of random, or not so random. We did took one of the resolvers, our customers, and asked them if we could sort of digest some data, and that we called it a day in the life of the resolver, a bit of similar to the day in the life on the internet collection that ORC does for the authoritative from the root. And out of that, we found out that roughly on a normal day, 11% of the queries on the DNS resolver are attack queries. Now, we don't see attacks running 24/7. I mean, we see attacks, but not the same attacks running 24/7. So keep in mind that while the attacks are running, the attack traffic can be easily half or even more of your total traffic that you see running to your server. So, but over the course of the day, it's roughly 11%. And out of that, most of it is random subdomain. There's still some amplification, as I said. Attacks don't go away. They just pile onto each other. And this is from that. There were 2 attacks, random subdomains attacks during that day. And one was 888fy.com. I don't know what these domains are doing, but that was used for the attack. And the other was bit16.com. That's probably some gambling site, I would assume. And we've seen that constantly. I mean, gambling, gaming sites are very prominent in being attacked. I don't know why, but that's just the case. And here's some more. Here's some sub-second, or actually second report on it. You see a large spike at the beginning, and then it kind of drives on. It's still, you see, it's one resolver, and it's 15,000 QPS over the course of the attacks that you just get from that attack, and without kind of the other traffic that you handle. So it can hit your resolver quite hard. On this attack, the bit16 attack, one IP sourced 9 million queries, and then we have 15 IPs that source the most traffic out of that. So this is actually a new trend that has less IPs, and 200 IPs in an attack is something that's not much. I mean, we've seen attacks with thousands or 10,000 of different IPs used. So that's actually a kind of small attack from the client distribution, but it's a huge attack because the clients are using much more queries. And with that, one of the things that you can do now with these kind of attacks, which didn't work with the other attacks that we saw last year, was to use client-based rate limiting, because that actually, with these kind of attacks, will work because the amount of traffic per IP is so huge that you just don't need to do that. The problem, though, with client-based rate limiting is that you also rate limit the good traffic. So, yeah, another thing we found is that that's more from research. We can identify the how do you call that? Probably the tool that they are using, because most of these things is done by tools these days. So you have a botnet creation tool that you put in the domain you want to attack, and then off you go. And the different tools have different random label patterns, so that's how we identify and kind of distinguish between them. And as I said, there's lots of stuff going on there, especially in the bot area, where there's still a lot of research I think we have to do. So attacks using bots will work like that. I mean, the ultimate goal is to take the website offsite. Now, because you can't get to a website without DNS, taking DNS out seems to be the way to do now, because it seems easier for them or for the attackers, because there's not much web stuff deployed as DNS stuff deployed as web stuff. And they do that by using an infected home gateway or an infected device, and then just that infected device has a resolver that's usually your ISP's resolver, and then they just push traffic at it, and the ISP resolver, this is my client, it's my customer, I have to answer the query, sends back the recursive curse to the authoritative server, which at one point just dies. And then if the authoritative server is dead, you can't resolve anything on that server anymore. You might actually have cascading failures, or you might actually also take down the ISP resolver, but you as an attacker don't care what you do. And how this is happening, we did some research on that, and a lot of devices, and that's something, if you think about the Internet of Things, that kind of scares me a lot. A lot of the things that are out there are very, very poorly configured, or not configured at all. And there are sites out there where you can basically fingerprint devices and then ask for the default password. And we had that numerous times, that use the default password on the thing from the internet, it just works. It shouldn't, but it just does. And of course, there are other bots there that can load code. I'm going to show you a bit of that. And that's research from IDG. The scans that they saw were about 50,000 per day in a research they did. So these scans are happening around your network all the time, and if you bring up a new device, it takes seconds for it to be scanned, and if it can be abused, it takes seconds to be abused. So it's a very kind of frightening thing. And another thing, a lot of these stuff uses OpenWRT or other Linux-based stuff. Now, the problem with that is if you configure it badly, or if you don't update it, these things become vulnerable. And I mean, most of the stuff have BusyBox, which is a normal shell where you can run stuff off. And you can, if you have a shell account on a Linux machine, well, we all know in this room, you're pretty much doomed. And that's what these attackers get on the box, is fairly easy. And another thing, once they are there, some of the bots that we see, and that's again from the A Day in a Life in the Resolver, that's the command and control queries we saw over the course of the day for the different bots there. And the bots in red are the ones that actually are capable of downloading additional code. So they are a bit like, yeah, you can, they might not attack you today, but if someone buys something for you to attack you today, tomorrow, they'll just do it. I mean, it should be clear by now that the authority attackers cause many problems. Some of the things I'm going to show is how attacks on popular domains make filtering a bit more complicated, because in the early days this was mainly Chinese gaming sites, and if you don't have customers in China, if you block Chinese gaming site, it's not a big deal. But if you block something more popular, it might become a big deal. And the home gateways that are still used actually masks the spoof IP that are used to actually attack you. So if you have a home gateway that acts as a DNS reflector, the address you see on your resolver is your customer's IP address. It's not the attacker's. And but there are ways to do around that. So the attackers actually have changed that. They now operate more with bots. And of course, if they take down the resolvers, they don't care. It's your customers that will then scream at you. And one of the things that I wanted to point out, that defenses have to change also. And the defense for stuff that was good 2 years ago might not be good now. So for me, the most prevalent example of that is the RRL. RL was there to protect authoritative servers against amplification attacks. So what it did, if you ask too many questions, it did send basically, you're probably an attacker. So if you're not an attacker, I want to serve you, but if you're an attacker, I'm just going to send you back a truncate bit. So if you set the truncate bit in DNS, it means retry over TCP. Now, DNS servers are equipped to handle thousands or millions of queries over UDP, but they are not equipped to handle millions of queries over TCP. So if you switch to the conversation between the recursive and the authoritative with the TCP, and you have a recursive server that does something like 10,000 queries over UDP just fine, and then you switch to the TCP, the recursor and the authoritative go down immediately. So my advice these day and age, basically, if you use RL, drop, not do TC, because a random subdomain attack might kill the authoritative and the recursive. Some of the stuff, though, while it has not been totally effective, has actually changed the landscape a bit. Now, a lot of people, and I think that was one of the comments on the last UKNOF, well, we just filter port 53 on the edge. Yeah, that'll work for a certain kind of attack, and that's why the attacker probably switched to botnets now, rather than using the open proxies resolvers. But it's still, I mean, the attackers just change, and it's not a fully remediation. And another thing is that DNS is UDP and is high packet rates, so the normal DDoS traffic that is kind of more based on streams and TCP won't work as good. And of course, in the initial days, there were scripts there for blocking stuff with IP tables. That's just too ineffective and not agile enough. Now, what we think there are two things that you could do for this. The first is to do ingress filtering on the resolvers, and the second is rate limiting the queries to the authoritative servers. And as every software developer these days, when you develop a new feature, the first thing that you need to do is to think about how to test it. So we did think, while we did the first thing, blocking queries first, when we did the second thing by doing rate limit to the authoritative, we thought about how would we test that, and that's the test set that we came up with. Basically, if you have the normal user traffic is just handling fine with the authoritative, and the authoritative has some kind of rate limit some kind of amount of traffic it can handle. And all that works fine, and then you inject attack traffic, and then you measure how good the user traffic that gets back is. So we use that to test our software, and we have implemented something for that now in our software, but no matter how we twiggled with parameters and how we did it, there's no way that you get all the user traffic back. You will, with that approach, lose some legitimate queries. There's just no way around it. But this is something, as I said, we work with our software, and then I'm currently looking into how other softwares, and that I'm probably going to talk about at DNS-ORC. So if you're in Amsterdam in May, feel free to come there. So that was basically just the text of that. So the challenge is protecting the good traffic. And one of the attacks that freaked me out recently, it was a very short attack, so I'll guess it was a tasting. It was an attack on Amazon.co.uk. Now, when you think about it, if your authoritative server is a Chinese gaming site or a betting site, your recursor farm might actually be able to handle that traffic until the server dies. So your recursor farm might not be affected. But Amazon.co, they probably have enough kind of, or they might have enough servers and stuff running around to actually answer all of the stuff. And then your recursor dies by resource exhaustions. So, and blocking Amazon.co.uk is something, I mean, I'm not sure anybody would want to do that. So as the attacks get to more prominent examples, you have to be very careful in what you do. And it seems to be there is a trend. I mean, we've always compare that to the Alexa 1 million list, and the initial attacks were not on the list at all, and now we are in the top thousands, with some of the attacks that we see. So that's not something you can just ignore. You have to be very careful on what you block. Now, here's what we do. So we want to whitelist legitimate queries. So we have actually, the first thing that we do, we put in a whitelist of the stuff that we know. And we do that by analyzing the traffic that we have. As said, we have terabytes of traffic. So we know over, say, the course of the last month or so, what questions have been asked. So we know what good questions have been asked on a domain. And then, depending on the attack, I mean, this attack, some of them are on the second level domain also. We then blacklist everything else. So in a case where the apple.daily.com is asked, we just, it's a legitimate query, we answer it. If the cache runs cold because of TTL, I mean, we usually prefetch it, but if it was a new queries, we will recurse it. If there's a question called VY or something, we block it. And I mean, another domain that is in a different sort of subdomain will just be answered over normal resolution. And by that, we actually think we can solve most of the problems of these attacks on the endbound. So we will not ask any of the bad domains to the authoritative server, so we're also protecting the authoritative servers with that. Oops, and that's now was too fast. I think there was one slide missing. So to sum up, I mean, there's DNS-DDoS is something that has been with us for years, and it keeps changing, and you have to adapt as good as you can. And we've so analyzed a lot of data and share that with the community here. So if you have further questions, feel free to approach me and ask them. Or of course, you can also ask them now if you want. So any questions? Yeah, Kathy.
Kathy Almond, ISC. You said that your testing strategy is going to be to monitor getting good replies back versus not sending bad traffic to the authoritative servers. Are you planning to measure good replies from all domains as well as the one that you're simulating the attack upon?
The current setup has a what I call test domain that is usually answered out of cache, but that has to be refreshed at some point. Yeah. So, but it's the main focus is really on the attack domains rather than the other traffic.
So you're not looking at hello. So you're not looking at the effect on the server overall as well as the specific domain that's under attack.
Well, what we do measure kind of the CPU utilization and stuff like that during the test, but we are looking at it from a client perspective. So basically, I'm as a user of ISPX, I want to get a good reply, and if I get a bad reply, then that's bad. So that we wanted to have it as kind of close to the user experience as possible.
Okay, and are you just going to test? I'm feeding you this question. Are you just going to test your own techniques, or are you going to test the techniques of other providers?
No.
As
I mean,
well?
the idea that we had it's another sort of research practice. We try to test whatever we can get our hands on.
Okay, thanks.
Okay, question here.
Lance, hello. Yes. Lance Right Knight. I'm curious whether or not you're finding any geographic trends on these attacks.
We have, so the open resolver stuff, we have a geographic distribution, so we know where that is. The main kind of, the main open resolvers out of Asia and South America at the moment. Europe and the US are a lot better. The geographic distribution to most of the attack is pretty global. So whenever an attack comes up, we see it at all our ISPs. It's not that they just appear on just one ISP. I mean, the bots that are there, if you have a bot in your network, which pretty much every ISP has, and that bot is used for the attack, you're getting attacked. So it's really, and it's funny because they have to have, the attackers also seem to have good mechanisms on monitoring, because as soon as the authority is dead, we see the attack dropping. So they don't want to waste their money.
And I guess the other question is are you finding differences between attacks based on IP4 or IP6?
Honestly, IPVs, I have to check, but I think currently the majority we see is V4. I don't think we see much in V6, but I'll have to check that.
Okay. Thank you.
Okay, any other questions for Ralf? Okay, thank you very much, Ralf.
Okay.